Hello, am I audible? Hello. Is my screen visible?
Yes.
Hello. Hello. Soil.
Yes, your screen is visible. It's visible.
Okay. So this is the very first problem of the today's contest. Maximize the last element. So let's read the problem statement first. It is said that we are given an array of n integers where n is odd. Uh, it is said that our operation is such that we will remove two adjacent elements from the array A, then concatenate the remaining part of the array A. It means that uh, the uh, the operation in one operation we can only remove adjacent element from the array A. It means that we can remove two adjacent elements like 4, 7, 7, but we cannot remove 7 and 2 because the two elements are not adjacent. Uh, and this was the definition of one operation, and it is said that we can repeatedly to perform some operation until exactly one element is left in array A, and we have to find the maximum possible value that is remaining in element in maximum value of the remaining element in array A. So let's take the case first. So if there is only one element, then we can say that that will be the maximum element. That will be 6. Now let's try to understand the this array 4, 7. Yeah. So if we will try to index the element 1, 2, 3, 4, 5, let's try to do some operations trivially. Let's delete first two elements. So we will remove first two index also. Then again remove first two elements because they are adjacent, and we now the remaining element is index 5. So this was the first operation. We can notice that this index is odd. So now again we will try to remove some elements. Let's take these two elements. We have removed this fourth and third and fourth. Yeah, and again try to remove these two elements. So what we can notice here is that whatever the operation we take on in any index, we will reach to a conclusion that the remaining element will always be a element that have odd index, because after removing all the elements, we will always see that the element that is remaining at the last is uh, the element which is present at the odd index. So and we have to take the maximum of all the elements that are present at the odd index. So here you can see that 1 and 2 are the elements that are present at odd index, 1, 2, and 3, 1 and 2, and we have taken the maximum of both of them. Similarly, here we can see that 1, 4, 4, and 9. These are the three elements which are present at odd index, and the maximum of all of them is 9. So 9 is the answer. So let's see the implementation of this intuition. So I have taken one element in variable maxi, and this is zero bit indexing. That's why I have taken this is even. So whenever this is the index is even, I have tried to maximize the element and output the maximum element. So this was basically the implementation of question A. Let's move to question B. Yeah, let's read the question statement first. It is given that we are given an array B of n minus 1 integers, and there is a definition of array to be a good array if pi equal to ai and ai plus 1. This means the AND operation of consecutive element of array A should be equal to the element of B, array B. for all integers that follow this constraint from where I start from 1 to and end at n minus 1. So let's take the test case. So if we take first test case, here it is set it n equal to 2 and element is 1. This means that b equal to b1 equal to 1. Since there is only one element, we can see that we can make array a as a1 equal to 1, a2 equal to 1, because the AND operation of a1 and a2 will give us b1 which is equal to 1. So this was trivial, so this can also be our answer. 5 and 3 can also be answer, but it is said that there are multiple solution exist, so we can make our own solution. So now take 2 and 0. So if we'll take 2 and 0, this is array b1 equal to 2 and b2 equal to 0. So let's try to make array A. So if we'll take 2, 2 and 0, we can see that the AND operation of both the elements will give us b1 which is equal to 2, and AND operation of these two element will give us 0 which is equal to this. This means this can be a good this can be a good array. Now let's see last test case first. 3 5 4 2. 3 5 4 2. Here it is said that p1 equal to if we will try to generalize array A. So let's say we have four elements a1, a2, a3, a4. So b array B will consist of three elements b2 and b3. So now b1 equal to a1 and a2, b2 equal to a2 and a3, and b3 equal to uh, wait, a1, a2, a3 and a4. So one thing to notice here is that uh, a2 is present in both b1 and b2. What is the meaning of this line, that a1 and a2 equal to b1? This means the element that the particular bit that is set in b1 must be set in a1 and a2. This should be the case. And what is the meaning of this line is that the particular bit that is set in b2 must be set in a2 and a3. This means that a2 must consist of the bits that are set in both b1 and b2. So this takes us to the conclusion that A2 must be must consist of the bits that are set in both B1 and B2. It means A2 is nothing but OR operation of B2 and B1 and B2. Similarly, we can try to conclude this for all the elements that comes in between. So A2 will be B2 and B3, OR operation of B2 and B3. So now, and A1, what will be A1 and A4? A1 also consists of the bits that are set in P1. It means that we can directly make A1 as equal to P1. A1 is equal to B1 because it will consist the same element, same bits as the set in B1. So A1 can be equal to B1. And what about A4? Similarly, A4 can be equal to B3 because it is affected by nothing, because it is only present in B3. So A4 can be the uh, A4 can be B3. This means that the first element of A can be equal to B1, and last element of array is equal to B3, and the element that comes in between will be the OR operation of the consecutive element of array B. So this was the whole intuition. Let's see the implementation of this code. Uh, so I have taken input in vector V, and I pushed the first element in temp, which is B1, and the last element in temp, and now for the middle elements will be equal to the OR operation of consecutive element of the vector. And now if after doing this operation, and we will not find that the consecutive end of the vector we have created is equal to bi, This means that our we cannot form any good arrest. So we have to return, we have to output -1, otherwise we have to output the answer we have created. So this was the explanation for P.
Hello, can you hear me?
Yes, I can hear you.
Okay, 1 minute, please. My screen is visible, right? Okay, so let's come to problem C. In problem C, we are given an array of n integers. In one operation, we can perform the following two-step move. We can choose some integer x, and we can replace each a of I with the modulus of a of I minus x. So finally, we need to construct a sequence of operations to make all of the elements of array A equal to 0 in at most 40 operations. So let's try and take a very small test case. Let's try and take the test case 0, comma 1. So we quickly notice that we can never make all the elements of this array equal to 0. Similarly, if we take suppose 2 and 7, we can keep trying different operations. Say suppose we take x is equal to 2, so we get 0 and we get 5. Let's take x is equal to 3, we get 3 and 2. Let's take x is equal to 2, we get 1 and 0, which is the same as this case. So obviously, I think it has already become pretty clear that we can't reduce this array to all zeros if the parities of the different elements present in array A are not the same. So basically, either all numbers have to be even or all numbers have to be odd for us to be able to make all the elements in the array 0. Is this clear or do you have any doubts so far? I think this was the obvious part. The more difficult part is coming up with a construction that can actually solve the problem. So my intuition was this. Basically, we have say a list of numbers 2, 4, 6, 12, 18, and so on. So what we can try to do is bring these two numbers closer together. So we need to increase this 2 somehow and decrease this 18 somehow. Or at least decrease this 18 somehow so that this of the the range of the array becomes smaller. So we're trying to reduce the maximum minus the minimum of the array. So one thing we can try is to take the average of the largest number and the smallest number. Here, the largest number is 18 and the smallest number is 2. The average of these two numbers is 10. So when we perform this operation with x is equal to 10, this number will become smaller and this number becomes larger. But more importantly, see, we see that the range has slightly reduced. There is a new smaller element and there is a new greater element, but the greater element has reduced. So now let's take 2 to be the smallest number and 10 to be the largest number and take the average again. The average is now 6. Again, we run this operation. We get this. So again, we see that the range has become smaller and the numbers are getting closer and closer together. Again, let's take this to be the larger number or this 4 to be the larger number and this 0 to be the smaller number. The average is 2. So we get this. Again, the range has become smaller. Now the average of 0 and 2 is 1, so all numbers become 1. And finally, when we take x is equal to 1, all numbers become 0. So this question is very hard to prove, I think. It required a bit of intuition that you're trying to make the larger number smaller, so you take the average between the smallest and the largest number, and that way the larger number gets reduced. Now the maximum number of operations required will be the logarithm base 2 of the max of this array and the min of this array. Is this clear, or do you have any doubts?
भैया ये लॉगरिदम टू मैक्स ऑफ ए माइनस मिन ऑफ ए कैसा होगा वो नहीं समझ रहा
So basically, in the best case scenario, right, the largest value is becoming half. So that's the intuition behind the maximum number of operations. I don't think this question and question C and question D were very ad hoc today. I think it required a lot of random insight, which is very hard to come by. But anyway, moving on to the, I'll show you the code now. Code is a simple brute force basically. Just pick the smallest and the largest, find their average, and reduce all the elements by that average. Okay, you can see the code, right? So here we check whether all the numbers are of the same parity or not. Either all numbers are even or all numbers are odd. If that's not true, we return -1. Now we keep running this while loop until all the values become 0. We take the minimum and we take the maximum through this for loop, and finally we calculate the new sum of this entire array, and we keep doing this until all the values in this array become 0. I hope this is clear. uh, Moving on to the next question. So in this question we are given an undirected graph with n vertices numbered 1 to n. There is an edge between vertices u and v if and only if u XOR v is a prime number, where XOR denotes the bitwise XOR operator. Color all the vertices of the graph using the minimum number of colors such that no two vertices directly connected by an edge have the same color. So the most interesting thing about this question is this is not actually a graph question. It's a mathematics question. It is presented like a graph question, but it's not. So let me teach you a short. Let me teach you a hack basically how you can figure out whether a question is you can figure out whether a question is actually a graph question or not. For example, let me show you. Okay, so what you can do sometimes is during a contest. Can you see the screen? you can press on this button to see all the submissions in a question. And if you look at all the accepted solutions, you see that all of these solutions use very little memory and they also use very little time. That gives us a clue that this is not actually a graph question, because if it actually were a graph question, we would be saving different nodes and different edges, which would make the memory of the solution go up significantly. You can see that most solutions here are under 100 kb, are under 50 kb in fact. So that gives us a hint that this is not a graph question, but it's a mathematics question or something that can be solved without using too much space. So that was the first hint to solving this problem. Now here comes the observation. Again, it's not the most obvious observation to have, but let's try and see anyway. Suppose we have some number x, right? And we have another number x plus 4. What happens if we take the XOR of these two numbers? So let x be some number. It's a random arbitrary number. I'm writing it in binary form, right? And we add 4 to it. Again, I am writing 4 in binary format. This is arbitrary. Now, when we add these two numbers, notice that the first two bits remain the same. So this remains a 0 and this remains a 1. Now, the first two bits remain the same, but the bits after that may change, right? That's okay. So we have 1, 1, 0, 1, 0, 1, 0, 1. We have this, and let's take the original number and perform the XOR operation. Now, um, since the first two digits did not change after adding a 4, we get a 0, 0. And then we get whatever, we get some other bits. It doesn't matter what they are. But here is the thing. So since the first two bits are 0, or actually more accurately, since the first bit of this is 0, that means this is an even number, right? And since this bit is also 0, that means this is an even number which is greater than 2. Any questions so far? So my claim here is x XOR x plus 4 is an even number greater than 2. Is this clear? Or do you want me to explain this again? Is it clear? If it's clear, react with a thumbs up. Otherwise, if you want me to explain this again, I can explain it again as well. So, this claim that x, okay, so this is not clear. Fine. So don't worry about where this observation come from. Let's just try and understand that x XOR x plus 4 is an even number, right? So again, we have some bits. This is some x, okay? We don't know what it is. If we find out the value of x plus 4, so if we add 4 to it, 4 in binary is this. So since the first two bits of 4 is 0, these two bits will not change in x plus 4. So this will remain a 0 and a 0. Now every other bit might change, but that's okay. It doesn't matter. So this becomes 0, this becomes 1, 1, 0, 1, 0, 1. Right. Now if we take the XOR of these two numbers, so 0 XOR 0 will be 0, These two bits will remain unchanged, like I said. So if same bits are XORed, then we get a 0 0, right? Then we get the rest of the answer as well for the other bits as well, but that doesn't matter. 1 XOR 0 is a 1. This is a 1. This is a 0. This is a 0 0 0 0. So we get this number. But the important thing about this number is the first two bits will always be 0. And if the first two bits are always 0, that means this number is an even number greater than is an even number greater than 2. Okay. So we have now established that x and x plus 4, if these two numbers are XORed, if x and x plus 4 are XORed, we get an even number greater than 2. Now, if the XOR of these two numbers is an even number greater than 2, that means the XOR of these two numbers is not a prime number. That means an edge between x and x plus 4 does not exist, right? So finally, if we have the nodes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on. For example, we have 13 nodes. Now x XOR x plus 4 is an even number which is greater than 2. That means that is not a prime number. So this is x and x plus 4 is this number. So there is no edge between these two numbers, right? So we can make them the same color. Similarly, between 5 and 5 plus 4, which is 9, there is no edge, because for there to be an edge, the XOR between these two numbers have to be a prime number. So again, we can color them the same. Here also we can color them the same. Now again, let's take 2. 2 and 6 will have the same color because there is no edge that connects them. So let's color this 2. 6 and 10 will have the same color because there is no edge that connects them. And so on. 3 and 7 will have the same color, and 11 will have the same color. Similarly, 4 will have the same color, 8 will have the same color, and 12 will have the same color. So we see that the answer is just 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and so on. Is this clear? So the main observation here was that x XOR x plus 4 is an even number which is not prime. So there will never be a edge between x and x XOR 4. That means we can always uh, color them the same. That's it. So if you look at the problem, if you look at the test cases, so for these smaller test cases, just output the same number. So for n is equal to 1, 2, 3, and 4, just output this, and beyond that, just output 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 repeatedly. So let's look at the code again. So here, if n is less than equal to 6, we just output whatever is in the given sample test case. Otherwise, we take a temp variable and we keep doing temp is equal to temp mod 4 plus 1. This basically has the effect of printing 1, 2, 3, 4, 1, 2, 3, 4 repeatedly. So the code is that simple. The observation part was the really difficult part in this question. Okay, I think that is it for today.